So are gas prices at the L2 pump getting you down?
Carpool with the BLS Wallet.
All right. Yeah, my name's James, and this is Jake, and we're from the the BLS Wallet team. Thanks. So we're one of several projects working under the privacy and scaling exploration of Ethereum Foundation, and we're going to tell you about what we're doing. But first, I'd like to start with, why are we all in this space? Why are we doing what we're doing? And the problem we all know is the cost per transaction problem, but I like to sort of translate it in terms of feasible dApps or feasible applications in the world. And so, with the high transaction costs, you've got a smaller amount of feasible applications, and then obviously as the cost goes down, you get to increase the amount of feasible applications that can exist. Add to that usability, then you can onboard a lot more users into this space and have a lot more impact more generally. So it's good to just keep in mind, keep in sight what we're doing. And what we have so far are applications around the DeFi space. Like say, DeFi front running can incur a lot of gas, and it's worth their while to do so. Hyped up NFT airdrops or NFT drops, people, aping into those, they can incur high L1 gas costs. And that's fine for that. High value asset transfers, sure, you can pay L1 fees. Now that we have rollups coming in, you can get to, broaden the amount of domains you go with, like casual gaming. But really what we want to get to is this peak up here, where we can say, look, we can have a greater impact on the world if we can have lower transaction costs. So you can, reach things like microfinance for developing countries because the cost per transaction needs to be really, really small. And, with the EVM rollups and BLS signature aggregation, we hope to sort of approach that and get closer to that, which is, hopefully why we're all sort of in this space. So what have we achieved so far? I like to sort of just wow you maybe with some numbers. So this isn't actually from L2 fees. It's just a representation of what we can achieve when we have both signature compression as well as some call data compression. And it's just an example that it's done with around 30 transactions. So compared to a single sending of a token or a transfer function on a token, you can get 45 cents or 30 cents on Arbitrum and Optimism. But when we bundled 30 of them together for a specific use case of the same sender of the same token, doing a transfer, then we could bring it down to 10 cents per transaction. So it's both signature aggregation, which is part of what we do, as well as the call data compression. Because it's smart contract wallets, we happen to get a lot of other benefits with it. So on top of the BLS signature aggregation, we can also then have gasless transactions where the dApps are paying the fees for the users, increase in usability, more impact, more people using it. Account recovery is another thing I managed to get in there, so that people don't have to worry about remembering their private key or losing their private key. It's just something that you can have as a backup. If you lose your BLS public key, you have a means of recovering it or resetting it. Upgradability. So in the future, there may be more features. There might be other signing schemes you want to introduce or anything else really, because it's again on the smart contracts. We can upgrade those, or it's again the choice of the user to upgrade their own wallet and the choice of them to upgrade what verification scheme they're looking at, like BLS and others. Also, we happen to put in there multi-action, so a smart contract that can do multiple transactions atomically. But I'll go more into that later. And these are things that Barry had mentioned earlier this morning in this room, as well as something that Vitalik discusses in 4.3.7 for layer 1, just to say, look, smart contract wallets or account abstraction bring you these things. So that's something we've also happened to get into this project. So where did we begin? Let's go to the origin of BLS Wallet within privacy scaling exploration. It's prior work all the way down. It's we're always building on the shoulders of giants, proven technology. Let's just go into what we're looking at with BLS. That's the researchers Bonnet-Lin and Shacham, if I'm pronouncing that correctly. In 2002, they created this pairing cryptographic-based signature scheme, and that's used for Ethereum phase 0 deposits. But the key attribute we care about is BLS signature aggregation. Now, previously I had a complicated diagram in here, and I was told that it maybe didn't make much sense, so I've kind of simplified it. So we have basically three signatures, if we will. So square is signing with blue, and circle is signing with red, and triangle is signing with yellow. It's actually harder than you think to say shapes and colors. Rather than submit each of them individually with each transaction, BLS lets us aggregate the signature in one and verify them all together. So rather than send 3 separate things, we're sending one thing. So when it gets to something like 30 transactions, we don't have 30 signatures that we're sending one. And just to, just to drill in that point, by reducing the call data on L2, that reduces the amount that's paid on L1, but I will expand upon that later. So Hubble used this around 2020 and into 2021 in a project that was focused on, it was an ERC20 focused optimistic rollup, and it didn't have EVM compatibility, but it did go and create these libraries, off-chain and on-chain for aggregation and verification respectively. And that's the repo there. Then, then late 2021, we started BLS Wallet, so I started working on the smart contracts first. And then we needed to build the aggregation service, so we got a team member on board for that. Then there was also the client module to be done, as well as the extension, and that's where the Hubble team joined us. So the client module is sort of small and meant to go within different wallets, and the browser extension is a prototype extension that we call Quill. That was, I just might add that it was designed with usability in mind, like multi-network usability, so a user should have a really good experience. So we did some user research just so that can, maybe just give an example to other wallets out there what is possible or what a user experience could look like. And and again, it's using the client module, so that's some example code there for any wallets. And so to drill in that point, that the L2 transaction data is kind of proportional to the L1 gas costs, because that's what is stored on L1. So by reducing that with both signature aggregation and TX data compression, then that's how we get the savings and reduce the per transaction cost, increasing the scope of dApps out there. For the initial graph that I showed you that I mocked up, these are, it was 30 transactions from the same sender to the same token contract calling the transfer function. And we kind of effectively compressed out those parameters because they were repeated amongst the 30, so we only needed to send it once. With the signature, we aggregated it, so we only sent one signature for all the 30 transactions. And if anyone's interested in the details, that's the report there. So the configuration we have today of those components is the prototype extension with the client module inside. The aggregation is running on our own server, and then those transactions are then fed to an L2 node. People can bypass that and send it straight to the L2 node without the aggregation, but so it's not like a bottleneck. People can still use this without the server. And then on chain we have the contracts of BLS signature verification and the wallets. And to go through it again, it's on the client side. The dApp will create what we call an operation, and this is terminology we've adapted from when 4337 was announced. The operations contain multiple actions. The dApp produces that for the user. The wallet then can sign that, and then you have an individual operation that has a BLS signature. Many different wallets are creating those in the space, and they're getting sent to the aggregator. The aggregator can then put those together and compress the signature, which is where that saving is, and any other compressions they wish to do with the call data. So there's a few other strategies that we hope to implement there and put inside this module. And then, we hope that L2 nodes will pick that up as well. And then once it's bundled together, it's sent to the smart contract that has an expansion. That does the expansion of the parameters. So if anything's, say, deduplicated, that gets spelt out again into the verification. So it's the full set of transactions that gets verified. So that's a bundle of operations. And then if verified, if they're all verified, then each of them can be executed with a smart contract wallet. I think that's it for me, if I'm not mistaken. I'll pass over to Jake.
Yep. Thanks, James. So now we're going to actually go through a demo of that entire component stack in action. We originally were going to have our team member, Katuk, present all of that, but unfortunately, due to some administrative issues, he was unable to make it. Hopefully, in the more open permissionless world we're building in the future, open borders will be a more common thing.
Hello everyone, my name is Kautuk Kundan. I'm here to represent the BLS Wallet team of the Privacy and Scaling Explorations Group at the Ethereum Foundation. I will be giving a small demo of the browser extension which we like to call Quill that complements the BLS Wallet work that we had been doing. Before we get started, I would like to thank Jake and James for giving me the opportunity to give this presentation even though I could not be there in person. So let's get started. Over here, I have a local environment set up for development. Inside this terminal window, we have a local hard hat node running, and I have gone ahead and deployed all the relevant contracts. In this terminal window, we have the aggregator, which will be listening for transactions coming in from the extension, bundling them together, and actually submitting on chain. In this terminal window, I have a sample application which will be getting into in just a minute. And over here, we have the extension where we'll be building the extension and importing into Chrome. So if I run this command, it will start the process of building the application. And once that is done, we can import it inside Chrome. All right. And now we move into Chrome. We click on load unpacked, navigate to the directory where the build output is, click on select, and we have the Quill extension imported inside Chrome. If we go ahead and pin this extension, so we have Quill next to MetaMask. Now I'll go ahead and click on Quill, click on get started. We'll be presented with an onboarding screen. I'll just go ahead and quickly fill in the details. So I'll type a small password. We click on continue, set a nickname for our wallet. So I'll just write ETH is the best because why not? And once that is done, the secret phrase for your wallet will be presented to you, which will contain 12 seed words because we are using a deterministic wallet method. Anyone who is using it to go ahead and write it. I'm a developer and I'm lazy, so I'm not gonna do that. And I'll just click on review secret phrase. I'll ask you to actually write a few random words from the secret phrase for confirmation. And like I said, I'm lazy. I have already given me prompts, and I'll just go ahead and fill these prompts. And once that is done, I can confirm this. In a moment, you will be presented with a screen with a wallet created. Now, if we go back into terminal, you can see a smart contract wallet was deployed for that particular account. If we come back and we click on add wallet, we can see that another wallet is created. It is also a smart contract wallet. So as I said, it is very intuitive for the user. They can just click a button and everything is taken care for them. Is the time for the sample application which I was talking about. Let me just move myself over here. This is a sample application which actually interacts with an ERC20 contract. Over here, it's just your wallet. You can mint token to yourself and you can approve different contracts to pull tokens from your account. And this particular component actually links to a spender contract, which actually has the ability to call transfer from your account and pull tokens into itself. Let's quickly check this out. So we have a wallet over here which starts with 86E4 and ends with 47B9. And onto this application, I'll just click refresh once and I'll connect to my wallet. So you can see that it's 86E4 and 47B9. So it's the same address which was actually used inside the Quill extension. Over here, you can see all the normal gRPC requests are working as they are expected to work. Now I'll just go ahead and do a transaction. I'll just call mint. And you can see it is going on. Let's just pretend there was a pop-up over here which we are still developing, similar to MetaMask, where you actually go ahead and confirm a transaction. We can see that a transaction was just minted and we have 10 tokens in our account. Now if we go back into the terminal, we can check this out. Over here we had a request for a transaction, and if we see, the aggregator actually performed a sequencing operation and actually submitted the transaction online. And over here we can see the submission attempt. This was the transaction request and it generated this particular hash, and it actually bundled a lot of hashes together. So right now it was just one transaction. So this was the hash created, but actually we can have multiple wallets interacting with the aggregator, and the aggregator can bundle all those different transaction requests into one single transaction and submit it on chain. Right now it's just one, so it's just one transaction request. Once that is confirmed, it is reflected over here in our application as well. Now I'll go ahead and approve these tokens. What this is doing is basically it is allowing this spender to pull tokens from this user. Now I will call pull tokens, and once that is done, we'll be able to see that these 10 tokens will be pulled from from the user into the contract. Let's give it a moment. All right, so the transaction just went through, and if we check out the logs, you can see that send transaction call was performed, which is over here. So you can see that it is using similar gRPC structure for regular send transaction method calls. And if we check out the aggregator once again, we can see that this submission was also confirmed. These are some things which any browser wallet can do. What we are going to see next is very specific to Quill. That is the most interesting thing that we are proud of Quill. What we can do is we can bundle the mint transaction, the approved transaction, and the pull tokens transaction into one single call, and Quill will handle it with grace. So if I call bundle up, you can see send transaction call was called, and inside send transaction, we actually had an array of 3 transactions which was requested. So you can see here this already succeeded. So the spender now has 20 tokens because 10 tokens were minted to the user. It was approved and it was then pulled in by the spender. And over here inside the aggregator, we can see that only one transaction was called from the aggregator. Okay.
All right, and so I'm going to stop it there. So kind of as we saw in that demo video.
Hello everyone, my name is Kautuk Kundan. I'm here.
I got it. Yep. So that was our Quill extension. That was kind of a demo of it interacting with the D app. For people who are interested in doing the same thing in your own wallet or in other applications, we do have an NPM package, BLS Wallet clients. We also use that inside of our aggregator. It runs in Node.js, the web browser, and it also works inside of Dino. And inside of that, you can see kind of a quick pseudocode example of how we are kind of instantiating all the different abstractions we have to make it easier to interact with all those clients. To keep this simple, basically what we're doing is we're connecting to the wallet that is on the that's already deployed. On the first transaction, when you run that, it's going to lazily create the wallet, and all of the wallets for the BLS wallets are deterministic addresses, so you know ahead of time exactly where that's going to be. And we also are doing some things to make sure that those wallets are deployed the same addresses across chains when possible. Then we're going to create and sign a bundle of operations. I'm going to get into some details on that in the next slide. And then optionally, you can aggregate multiple bundles together. So we'll get that signature aggregation, and we will also get all of those operations aggregated together. And then finally, we're going to connect to our aggregator instance, which is just going to be over HTTP RPC, and then we're just going to submit that in. So to go into more details of what that bundle format looks like, this is in TypeScript, but it's very similar to what it will look like on the Solidity side as well. For that, we're going to sign an operation. We're going to use the wallet nonce, so that would be the on-chain smart contract wallet. And then we're going to have an array of actions. All of the actions are going to be atomic, so if one fails, the entire operation will fail. But within a given mass bundle of operations, each operation can kind of succeed from different wallets independently. So in this case, we're doing an actual prove and like a theoretical swap with a DEX. For this, we're listing no ETH value being added to that transaction. We're specifying the ERC20 contract address, and then we are doing an encode of the function data with the method call and then the parameters for that. And then directly after that, we're going to call into the actual swap function, moving that around. So instead of having to do 2 separate actions inside of a UI or wait for one transaction confirmation before going to the next, you can just do it all at once instead. So that's kind of where we are right now, and we want to kind of go over some next steps for where we want to take the project and how we want to integrate it more into the wider ecosystem. So for future configuration options, right now, James went over kind of how we have our current setup with the extension prototype and the client modules. We would like to move more to having our client module directly integrated into wallets in the ecosystem, and then as well as having our aggregator logic aggregated directly into L2 nodes, so people could sign transactions with BLS signatures and just submit them directly there, rather than go through yet another middleman to get them in and get them compressed in. And then the final part at the actual Solidity or smart contract layer, having third-party contract wallets using our BLS verification gateway. So for existing smart contract wallets can take advantage of these BLS signatures. We're starting this with a little initiative we call Web3 Well, where we're trying to put together a team to essentially integrate in all of these features into existing wallets and existing platforms to just get faster adoption going for these benefits. We're also working on improving our repo dev docs, which need a little TLC. And we're looking at having some kind of well-defined issues inside of the repos that we're going to contribute to kind of sort out the best way to integrate in. As everyone is, we're hiring. If you're interested, come talk to us after the presentation. And keep in mind as well, on top of all these things, just to reiterate what we covered, you get the BLS signature scheme. You get gasless transactions where DApps can pay for those transactions, or you can have more novel transaction payment schemes. We have account recovery, so as people mismanage their private keys, as they inevitably will, they'll have options to recover that out. You have upgradability if you want to add new features to your smart contract wallet. And then obviously the multi-action, so you can take many different clicks off of your UI and just put them into one. So come quench your thirst from the Web3 well. We have a Discord server up that you're welcome to join and chat with us more about the project at. And then our repo is located at Web3well, BLS Wallet on GitHub. And we love new issues and discussions inside of that repo. Thank you so much.
Any questions?
I think the lady there. Oh, no, I was just waiting. Okay. Hey, really cool, really enjoyed that. I wanted to ask, if I'm a protocol or I'm building some sort of a dApp, and I'm interested in some of these features, how would you envision integrating some of these into the application?
I think mainly it kind of depends on what layer of the stack you're in and where you want to pull that in. If you're more of like a wallet, we have that client library where you'd have access to that. If you're integrating more at like the maybe node level or at the smart contract level, you would probably just pull in like our deployed contracts or point at them. And we have them currently on Arbitrum testnet, but we can go to other networks. And then you basically would just interact with the like interface we have for either the gateway or the wallets that are on there. Did you want to touch them on that as well?
And did you say you were a dApp as well?
Yeah, if I'm working on a dApp,
Yep.
some sort of DeFi dApp that I'm interested
Yeah.
in some of these.
So dApps today, they don't need to be changed to be used with the extension, but to take advantage of the multi-action, you would need the users to have a BLS wallet. And then you could structure things differently to say, rather than sign an individual transaction, you would sign maybe a set of actions in an operation. So that would change the structure there, but again, that would rely on the users having that. So in the same way that dApps today prompt a user to install MetaMask, you can have them say, oh, install this other extension. And, we have Quill as an example, but there could be eventually other wallets that will include it. And then you could point them to those ones.
Thank you.
So I'm curious about the limitations, what can be aggregated and what cannot be aggregated. Specifically, like different public keys, like different
Yeah.
addresses.
Yeah, in terms of signature aggregation, it is like if it's signed with the BLS scheme, then those can be aggregated, and that's just that. In terms of the call data, like parameters and whatnot, the example I gave was sort of like a naive implementation of deduplicating parameters. So if they all happen to be the same, you could take them effectively, take them out and then expand them. In terms of other compression algorithms, they have been explored independently, and we could bring them in to the relevant section of compression in the aggregator and then expansion on chain.
Yeah, so actually not about compression, just the aggregation.
Yep.
So basically different public keys and different messages.
Yeah. So the complex diagram that I got rid of was sort of showing that. But yeah, imagine the shapes again. The individual individual public key. Everyone's public key signs their own message. Yeah. It was in the complicated diagram, but
Anyway, it's complicated math. Do you have it actually written somewhere?
Oh, the
I could review?
BLS. That's again on the shoulders of giants. Yep. So if you look them up.
But in this paper, there is no aggregation whatsoever, right?
Okay. So there's the maths that, maybe it's not in the 2002 paper. There is later work that talks about the aggregation. But yeah, I'm not sure.
So basically, I'm pretty much aware of that. And the only thing I'm aware of, and this is why I'm asking actually,
Sure.
is that you could aggregate signatures from different public keys, but they have to be signed. They have to be signing the same message, not different messages.
No, I should have left the complicated slide there because it had a link to the. But there's several resources that show that you have an individual private key signing their own message, and each of them will create their own BLS signature. Those signatures can be compressed into one, which is just by addition. And then for verification, you send the public key and the corresponding message as an array, and that's what the library does. That's what Hubble BLS did originally. Okay, and then those are sent in an array, and all of that is verified against the aggregated signature.
I get it. No, all good.
Yep.
So yeah, basically you said at the very, very beginning that you won't have to send all the signatures.
That's correct.
This is still correct, but what
Yes.
you're saying now is that you still have to send the public key, the original public key,
That's
and the
correct.
message. Okay.
Yes.
Yeah.
Yep.
All
You
good.
have to send each of them. Yeah. Definitely. Yep.
One last quick question.
So you said you have deployed an Arbitrum testnet. Does it mean you mainly focus L2, or does all of that work for L1 as well, right?
Yeah, it can work on L1, but it's sort of there isn't much of a saving in terms of the compression. In terms of the smart contract, well, yeah, it's sort of we didn't intend it to be. Although I'm sure the code can be used in that sense, like the smart contract can be. But yeah, the benefits are there for any EVM-based rollup.
Okay.
So right now it's Arbitrum and Optimism, and we will be deploying to those testnets, the
And
mainnets.
what do you see
and
as
ZK EVM down the
And
line.
what do you see as the main challenge for adoption?
Good question. Do you have thoughts on that?
I think the first step is probably just getting some wallets to include it, maybe even as just an experimental feature for people to play around with. It would also be good to get some dApps kind of trying the gasless transactions, so you can get people onboarded really quickly and without having to like go out and buy something, say on an exchange, and bring it in. I think once you can see kind of the benefits of those use cases, it starts bringing more and more people in and kind of creates that snowballing effect of people wanting to use it. Yeah.
Okay, thank you.